Hello friends, continuing with the topic of significant figures, today we come to rules for uncertainty of a number in a mathematical operation. I repeat that today's topic, rules for uncertainty of a number in a mathematical operation. First we take up addition subtraction. Now uncertainty or an error of an instrument is normally half, that is 0.5 of the least count of the instrument. I repeat, uncertainty or an error of an instrument is normally 1 by 2 or 0.5 of the least count of the instrument. For example, length and breadth of a thin rectangular sheet is measured to be 16.2 centimeter and 10.2 centimeter respectively with the help of an instrument with a least count of 0.1 centimeter, that is meter scale. Now in case of length 16.2 centimeter, significant figures are 3, and in case of breadth 10.2 centimeter, significant figures are also 3. Now length can be written as L equal to 16.20 plus minus 0.05 centimeter. Since 0.05 is 0.3% of 16.20, therefore length can be expressed as 16.20 plus minus 0.3%, because 0.05 divided by 16.20 into 100 is 0.3%. Okay. Now similarly, breadth can be expressed as B, which is equal to 10.10 plus minus 0.05. Since 0.05 is 0.5% of 10.10, therefore breadth can be expressed as B equal to 10.10 plus minus 0.5%, because 0.05 divided by 10.10 into 100 is 0.5%. Now rule 1. Percentage error or fractional error of a value of a number specified to n significant figures not only depends on n but also on the number itself. Lower the number, greater is the percentage error. I repeat, rule 1. Percentage error or fractional error of a value of a number specified to n significant figures not only depends on n but also on the number itself. Lower the number, greater is the percentage error. Now you see here length is 16 point something centimeter and error is 0.3%, and breadth is 10.10 centimeter and error is 0.5%. So lower the number, greater is the percentage error. And now rule 2. If a set of experimental data is specified to n significant figures, then a result obtained by combining the data will also be valid up to n significant figures. I repeat, rule 2. If a set of experimental data is specified to n significant figures, then a result obtained by combining the data will also be valid up to n significant figures. For example, we have two values 12.9 gram with 9 as uncertain. Now significant figures are 3, and another value is 7.06 gram with 6 as uncertain digit. Again significant figures are 3. Suppose these are to be subtracted. The resultant value after subtraction would be 12.9 minus 7.06 will be equal to 5.842. The result must be expressed to 3 significant figures, that is 5.84. But according to rules of significant figure, for mathematical operation, the result must contain decimal places least in the inputs. Therefore, result is expressed as 5.8 grams. So according to rule of uncertainty, it must be 5.84, and according to rules of significant figures, it must be expressed at 5.8 gram. And now rule 3, case of multiplication and division. When two or more experimentally obtained numbers are multiplied, the percentage uncertainty of the final result is equal to the square root of the sum of the squares of the percentage uncertainties of the original number. I repeat, when two or more experimentally obtained numbers are multiplied, the percentage uncertainty of the final result is equal to the square root of the sum of the squares of the percentage uncertainties of the original number. Now consider the area equal to length into breadth. We use the previous data which was used in previous examples. So if length is 16.20 centimeter and breadth is 10.10 centimeter, then area would be equal to 16.20 plus minus 0.3% centimeter into 10.10 plus minus 0.5% centimeter. So 0.3% is error in length and 0.5% is error in breadth. Now percentage uncertainty in final result would be equal to under root of 0.3% square plus 0.5% square, and it will be equal to 0.6%. Now original area is equal to 16.20 into 10.10, that is 163.62 centimeter square. Therefore, final result is expressed as 163.62 plus minus 0.6% centimeter square. If we add the uncertainty, then it comes out to be 164.52 centimeter square, and if we subtract, it comes out to be 162.72 centimeter square. I repeat, if we add, we get the result as 164.52 centimeter square, and if we subtract, we get the result as 162.72 centimeter square. Okay. Thank you so much. God bless you.